Hi everyone. Today I will discuss about the kinetic theory of gases, lecture 4. So, plot of Maxwell Boltzmann distribution of speed. From the previous lecture, I discussed about the three-dimensional Maxwell Boltzmann velocity and speed distribution. So, now I am talking about the plot of this. So, the speed distribution is generally represented by a plot of 1 by n dnc by dc versus c. So, where 1 by n dnc by dc is known as fraction of total number of gas molecules present between c and c plus dc per unit interval of speed. Next, when c tends to 0, the exponential term is almost a unity. So with increasing c, exponential term dominates the behavior of the functions and therefore the exponential fault is observed. Due to the behavior of these contrasting terms, the distribution functions passes through a maximum. The speed of the gas molecule corresponds to the maximum. The speed of the gas molecule corresponds to the maximum is called most probable speed. That is very much important. Next, so qualitative features of the curve. So for the Maxwell's Boltzmann three-dimensional velocity and speed, we will get this type of curve, that is where in two different temperature, where T2 is greater than T1. So the number of molecules having very low speed, that is c tends to 0, and very high speed c tends to infinity would be small. These are the qualitative features of this particular curve, where we plot c in the x direction. C is the velocity of the gas molecules in meter per second, and 1 by n dnc by dc is the probability of finding the molecule in c and c plus dc velocity range. Next, the qualitative features second says that the curve was maximum speed corresponding to the peak representing the speed caused by the majority of molecules. This speed is called most probable speed and it is denoted by CMP. With variation of temperature, separate distribution curves are obtained. At higher temperature, there are wider distribution of speed, which means at higher temperature means that is T2. Here the percentage of the molecules increases. So at higher temperature there are wider distribution, and the percentage of the molecules in higher speed increases with increase in temperature and decreases in the lower speed decreases. So next, the maximum shift to the right hand curves are broadens with rise in temperature. The magnitude of CMP is also increases. The speed distribution also depends on the mass of the gas. That means if we take two kind of gases of masses, then it will give the two kinds of graphs. So a heavy gas has narrower distribution speed than the lighter gas. That means the gases having greater mass has a narrower distribution speed than the gas having lighter mass. Next, the area under the curve at two different temperatures will remain same because it represents the number of molecules present in a system. Next, determination of most probable speed from Maxwell distribution. It is very much important. So from the Maxwell distribution, we have to determine the most probable speed. The most probable speed is the speed possessed by the maximum fraction of gas molecules. The expression of the most probable speed can be derived mathematically is as follows. So let's see. From Maxwell speed distribution, we have 1 by n dnc by dc equals to 4 pi m by 2 pi kt to the power 3 by 2 into c square into e to the power minus mc square by 2 kt. So we have to start from the Maxwell speed distribution. Next, we have to differentiate it with respect to c. Then we get d dc of 1 by n dnc by dc is equals to 4 pi m by 2 pi kt to the power 3 by 2 into ddc of c square into e to the power minus mc square by 2 kt. Here 4 pi m by 2 pi kt to the power 3 by 2 will be taken away from the derivation part because it is all constant. So now we have to differentiate only c square into e to the power minus mc square by 2 kt. So here we can differentiate is as a rule uv. We all know that in HS. So first we have to constant one part and then differentiate the other, and then plus we have to constant the other and take the other differentiation the other part. So then we get this value. So this will be the value. Next, now at maximum point ddc into 1 by n dnc by dc will be equals to 0. That means this part will be equals to 0. So also this part also will be equals to 0. So this part will also be equals to 0. So there are three obvious probability. First is c is not cannot be equals to 0, and the other, that is the exponential term, it also cannot be equals to 0. So only one possibilities can be possible. So the only the other possibilities is the first two probabilities corresponds to the minima. When c tends to 0, dnc tends to 0, that, and when c tends to infinity, dnc tends to 0. So the only third condition satisfies the maxima. That means the third condition means this particular value. So this particular value can be possible. That is 2 minus mc square mp by kt equals to 0. So from there, if we solve these, we can get the value of cmp. So therefore cmp equals to root over of 2 kt by m, and also if we put the value as a universal gas constant, then we can say cmp equals to root over of 2 RT by m for 1 mole of gas. Thank you so much.